solve with you a tutorial on the proof. And inshallah, by next week, on Monday, I will not meet you on Monday, but I will meet you on Wednesday. And in Wednesday, we will take another tutorial, maybe 2 tutorials, and I will post for you the last homework number 3. In homework number 3, we will have 3 problems, one related to proof, one related to set, and one related to functions. Let me share with you my. Yes. Sometime when you are solving a problem related to proofs, the question will be prove or disprove. So it's something different than if they say just to prove. If they say prove, معناتها the statement is true. You can prove it using one of the methods. And actually we have 3 methods. We will discuss them later. But if the question said prove or disprove, معناته we are not sure that this is a true statement. You have to check first. And if you remember, we discuss prove or disprove depend on the quantifier itself. So some statement they are coming in a general form. يعني هني for any كلمة any معناتها automatically that this is a universal statement. You are selecting any 2 integer numbers. So it's a universal statement. To prove it, you have to check every element in the domain. To disprove it, you have to give counterexample. We are talking about universal statements, الجمل اللي تصير بصورة عامة. In this case, to disprove, you have to give counterexample. Just give me numbers, integers. Here in our case, the domain is integer. Just give me 2 integers, m and n. When I substitute in 10m n plus 7, I will get even number. معناتها it is invalid. If I cannot find any of these 2 integers, any one of these 2 integers, so in this case, it's look like that this is a true statement. Now, to say it's true, you have to check every element in the domain, but actually, the domain is infinity. How can I check everyone? That's why we go for a proving method. And with the proving method, we have 3 kind of methods. أول واحدة direct proof. من اسمها direct proof يعني direct from left to right, and that's it. You will simplify it directly. If you choose the contrapositive, معناته this statement cannot be proved directly. But because we know that the contrapositive is logically equivalent to the statement itself, we will think about a proof by contrapositive. شو معناته؟ I will prove the contrapositive directly. يعني أنا ما راح أثبت الجملة بس راح أثبت الcontrapositive مالتها because they are logically equivalent. How to prove the contrapositive? Directly. Okay? And the last kind of proving اللي هو proof by contradiction. I cannot prove the problem, and usually we use this technique إذا كان عندي not equal. Not equal, I cannot prove it mathematically directly. يعني ما أقدر أثبت شيء إن this is not equal. I can prove the equal case, but not the equal case. So I will assume that the negation, the equal is true, then I will try to find a contradiction within my assumption. يعني this assumption is something impossible because it's contradict with itself. That's why it's impossible to happen. So my assumption falls. The original statement is true. So we have 3 different techniques, 3 different proving method, and each method can be used in some cases, special for some cases. And you will find that some problem I can prove it using the 3 methods, and some problem the direct is the suitable one, some of them the contrapositive suitable one. We will go through some kind of a problems to see when we can use each kind of method. Now let's see the question here. For any integers m and n, the term 10mn plus 7 is odd. And try, select any two random integer values and substitute. You will get always odd term. So let's look that this is a true statement. So I have to prove it. Prove it, I have to select one of the method. Which method I should use? I will use a direct method to prove it. Not always you have to put the symbolic form, but I keep it in front of you just to help you. For any integers m and n, اكتبها for all m and n belong to z. 10mn plus 7 is odd. كلمة odd we represent it in a form of 2k plus 1. The general form of odd is 2k plus 1, 2w plus 1. So now here, if you look over the symbolic form, you can see that this is the left-hand side equal right-hand side. If you can move from the left-hand side to the right-hand side with small simplification, معناته you can prove it directly. Okay? So when I decide that I will prove this method directly or by contrapositive or by contradiction, it's very important to mention the method very clear, because the one who will correct for you should know which method you are using to check if you are applying the method correctly. So the first step, you should mention that I will use the direct method. And because I'm choosing a direct method, I have to write what is my assumption, what is the to show steps. These two things should be written very clear. Because if I want to prove the direct, my assumption will be something different if I want to prove it by contradiction. So it's very important to write these things very clear so the one who correct for you know that you understand how to solve the problem. So here I will use the direct method. This is the first step. The second step, according to the direct method, what is my assumption? What is my task to do? What I have to show? في الدايركت method الاسsumption will include the domains and the premise if you use if you have implies statement. In our case there is no implies statement فما عندي premise أصلا. Okay, but in case I have a premise in my statement, so remember the assumption في direct technique include the domain. معناتها it say that I have two integers m and n. In addition to that, the premise. Here there is no premise. So my assumption in my case now, only the domains that I have two random integers. You can write the assumption in English or you can write it in symbolic form. It's up to you, but it should be written very clear. What is my task to do? What I have to prove? I have to prove the statement that 10mn plus 7 is equal to 2k plus 1. إذا كانت عندي implies statement, the conclusion will be my task to show. Remember this. Now, my task said I have to prove that 10mn plus 7 is equal to 2k plus 1. Direct. يعني أخذ the left hand side and I try to simplify it to reach the right hand side. So I will start with 10mn plus 7 equal to, and I will do some mathematical simplification to get the form 2k plus 1. My goal is 2k plus 1. What I have here is plus 7. I need the constant one to be plus 1. So what I will do, I will remove 7 and I will substitute with 6 plus 1. Do I change anything? No. I'm just taking 7 and I put 6 plus 1. Now, plus 1 plus 1. What I need here, 2k. Look over this subterm, 10mn plus 6. This is an even term because I can take it 2 as a common factor between 6 and 10. So easily I will take it 2 as a common factor. What I get here is 5mn plus 3. Now this is can be written in a form 2k plus 1, 2w plus 1, whatever. The most important thing when you are showing odd or even case لازم ال k should be an integer value. يعني لو كان هنا عندي 11 I cannot take it 2 as a common factor because when I take 2 I will get here 5.5. And 5.5 is a real number. When it's multiplied by any integer, it will give me a real number as a result. So the k is not an integer. When you're writing odd or even or even in divisibility forms, we will look over them later. The variable k, w, whatever you write should be an integer value. So make sure that when you take something common factor, the variable should be integer, not any other type. Okay, so this is how we go and prove the method directly. Again, I will repeat, you should mention the method here very clear, especially if the question did not say prove it by this method. You have to decide, so you have to write very clear which method you are using. According to the method, what is your assumption, what is to show, and then from left to right to try to find out the result. This is another question, said prove or disapprove. We are in the same question, question number 1. For all m and n belong to z plus, يعني any two positive integer because the domain says z plus, so I don't care. My domain only the positive numbers. And the positive integers including 1, 2, 3, 4, 5 is 0 is not there. So you have, when you give me counter example, you should give me something belong to z plus because my domain is z plus. The statement said if m is greater than n, then I can conclude that m square minus n square is a composite number. And we say composite معناتها not a prime. The numbers in Z either be prime numbers أعداد أولية أو composite number. So when they said composite number معناتها you will get a non-prime number. Now, to say that this is true, you should select all random number, all random combinations in Z plus بس بشرط ال m should be greater than n and you always find that m square minus n square is a composite number. What do you think? Is this true or false? If it's true, you have to prove it because the domain is infinity. If it is false, you have to give counter example. What does it mean counter example? You should give me two positive integer يعني ما حد يعطيني قيمة negative. They should be positive integer. 0 is not positive such that m is greater than n يعني true premise but false conclusion. الconclusion شلون يكون false؟ لما يكون m square minus n square is a prime number. What do you think? Is this true or false? Try small numbers. You will find if it is true or false. if I try small numbers, for example here 2 and 1. 2 and 1, both of them belong to Z plus. 2 is greater than 1. But here 4 minus 1 is 3 and 3 is a prime number not composite, so false conclusion. يعني أول رقمين في الدومين جربتهم طلع لي إن هي false. So this is false statement. And remember, the good counter example should be two numbers belong to Z such that your implies statement should be T implies F. And you can put any values. Can give ممكن يكون عندي more than counter example. What about this question? Prove or disprove? If you look over the statement, it said n squared plus 1 greater than or equal 2 to the power n, where the n belong to Z plus and the n between 1 and 4. Your domain is Z plus, the integer values. And here we have another condition that n should be between 1 and 4. For such kind of questions, if your domain is limited, because the integers between 1 and 4, they can easily be listed to be 1, 2, 3, and 4. Just check every one. No need to use the proving method because if you use the proof method, it's fine. But even though you can check everyone in the domain, because we use the proving method if the domain is infinity, we cannot check everyone. Here in our case, if you are good in mathematical skills related to inequalities and you prove it, it's fine. No one can say that this is false. But another student, they may think about it's only about for iteration. I can check everyone and that's it. So for n equal 1, I will check, I will substitute, and I find that 2 is greater than or equal to 2. It's true. Do I have to stop? No, because this is not exist statement. It is a universal one. معناتها I have to check everyone, and it should be true for every element in the domain. It's also true when n equal to, because 5 is greater than or equal to 4. When n equal to 3, 10 is greater than or equal to 8. When n equal 4, 17 is greater than or equal to 16. And because it's true for every element in my domain, so I prove it by testing everyone. I do not use the proving method. Okay, so we use the proving methods لما يكون الجملة صحيحة, universal. Remember this, it should be a universal statement وتكون a true statement and the domain is infinity. We will think about the proving method. الexist statement تكون true by giving example. يعني this statement said there exist n belong to Z such that 2n square minus 5n minus 9 is a prime. Can you search among the integer values and find value of n that when you substitute in this term you will get a prime number? Prime number معناته شنو؟ Prime number العدد الأولي. Prime number you can list them in math. 2 is a prime number. 3, 5, 7. There is no such general form for prime numbers. But you should know some fact about the prime numbers. And the prime numbers, all of them are odd, except number 2. 2 is the smallest prime number, and 2 is the only even prime number you have. Well, the prime number, the factor of the prime number is the number itself and 1. L1 is not a prime number, so never give me a value of n that make this term equal to 1 and say that 1 is a prime number. 1 is not considered to be prime number لأن شروط البرايم number يكون عنده two distinct factors and ال1 عندها just only one factor. Can you find the value of n that make the term prime number? Actually, this is a true statement. And when you choose n equal to 4, and 4 is a number belong to Z, and you substitute here, you will get 3, and 3 is a prime number. So, the exist statement, to prove it, no need to prove using the methods. Just give examples. Now, the second question said, prove that the difference between the cube of any two consecutive integer is odd. إيش معناته؟ معناته the difference، كلمة difference يعني الفرق between the cube power 3 of any two consecutive integer is odd. This statement is a universal statement because of the keyword any. I prefer that you write the symbolic for it, so easily you can decide which method you should use. So I will convert this for you into symbolic form, but this is not part of the answer. If you can guess the method and you can guess the assume to show, it's up to you, okay? But I prefer converting it into symbolic. And we know how to convert because we take this task in the last chapter. So here, any two integer, that means I have two integers. I can select any variables. I select here n and m belong to z. هاي معناتها any يعني for all, integers يعني z، وعندي two variables فحطيت n and m, a and b, x and y. Okay, you can select them. So these two, any two integers معناتها for all n and m belong to z. Before the keyword integer هني عندي adjective consecutive. كلمة consecutive they are following each other. يعني 2 و 3 4 و 5 لازم يكونوا consecutive. Okay, so this is because this is adjective and we have a universal quantifier. شو نحطها؟ نحطها في premise side. معناته n and m are consecutive. If they are consecutive, then I can conclude that the difference between the cube. This is my conclusion now. The difference between the cube is odd. What does it mean? It means in m cube, n cube, whatever the difference يعني الفرق بينهم is 2k plus 1. So now, if you look over the symbolic form, which method is the most proper one? أروح إلى proof by direct أو proof by contrapositive أو proof by contradiction. من أشوف إن الكيوبينج السكويرينج موجود في الكونكلوجن مو في البريمس، خلاص الكونترابوزيتيف بكنسلها. It's not a proper method. Okay, if you look here you will find that you have information about n and m without cubing, without squaring. في البريمس side the most proper method is direct. مو دائما but usually you will think about it in this way. ليش؟ لأنه we can calculate الكيوب من ال n. يعني I am assuming something about ال n. Can I find out directly what is n cube؟ إيه أقدر. I بعوض عنها وراح أسوي distribute الباور and I will go further. بس لما يكون عندي الكيوب أو السكوير موجود في البريمس سايد صعب directly إني I calculate ال n from ال n cube because I will deal with الروتس. فاحنا دائما لما يكون عندي مثلا n و m even او odd موجودة في البريمس side we think about the problem directly. ليش؟ لأنه when I choose a direct method my assumption وش قلنا من ساعة؟ الأسيوم الدومين مع البريمس they should be included in the assumption. So I will assume that n and m belong to z and I will assume that n and m are consecutive. شلون أعبر عن الconsecutivity؟ أعبر عنها إن I will say one of them is equal to the other one plus one أو minus one. It's depend. how you represent the consecutive. Now I present the consecutive in a form of that ال n is equal to m plus 1. ممكن طالب ثاني يحط ان ال m is equal n plus 1. ممكن طالب ثالث يقول ال n equal to m minus 1. كلها تعبر عن ال consecutivity. الحين أنا عبرت عنها البريمس بأن ال n equal m plus 1. My task to show is the conclusion. N cube minus m cube is equal to 2k plus 1. My task is to calculate n cube minus m cube and find that the term I get is odd term. فببدي بال n cube minus m cube. n cube minus m cube. How can I simplify it? بستخدم my assumption. What do I know about ال n or ال m? I know that in ال n equal m plus 1. So instead of n cube, I will calculate m plus 1 cube. فأعوض ووزع الباور. فبصير عندي m cube plus 3m square plus 3m plus 1 minus m cube. m cube minus m cube 0. فيبقى لي 3m square plus 3m plus 1. My goal is 2k plus 1. بس شنو صار عندي هني؟ 3k plus 1. 3k plus 1 that يعني does not present ال odd form. ال odd form لازم يكون 2k plus 1. So plus 1 is already here, plus 1. So we will keep it. What is common between 3m square مع 3m? The common is 3m. So I will take 3m as a common factor. What is left here is m. What is left here is 1. If you look over the term 3m times m plus 1, is this an even term? If you look over it, you will find that m is multiply m plus 1. And you know fact that the integers, because here our domain is integers, okay? The integers are coming in order, even followed by odd, odd followed by even followed by odd, and so on. They are coming in sequence. فإذا الm كانت even, m plus 1 بتكون odd. وإذا الm كانت odd, m plus 1 بتكون even for sure. And the product of any two consecutive numbers is always even. How can we say these things in our proof? When you are stuck and you cannot continue proving, for every integer number m, I will divide my integer domain in two groups. فنروح حق شيء اسمه cases. So cases is not a proving method actually. It's a technique that you are stuck. You cannot prove for everyone. You cannot continue. Now, if I stop here, how can I show that this is a 2k? I am stuck in the middle. So I will think about dividing the domain Z in two categories, even odd. هل لازم دائما even odd؟ لا. We will see another problem that will divide the group in something else, in some different categories. But when you divide the Z under these categories, you are checking everyone in Z because the numbers in Z either even or odd. فلازم تشيكون ان ال cases all together should represent your assumption domain, ال assumed domain here Z. فلما اروح اشيك ال even numbers بروحهم و I check the odd number alone in a different case, معناته I check everyone in Z. So I will go for the cases because I cannot continue proving it. What is the possible case categories I need? قسمتهم إلى even and odd because the product of any two consecutive numbers is always even. فقسمتهم إلى هاي الcategories. When ال m is even, I will just remove ال m and I will put instead 2k. So I will continue from where I stop here. I will say 3 instead of m, I will put 2k. And instead of m here also I will put 2k plus 1. Now there is no need to distribute, by the way. 3 times 2 times this parenthesis, that means 2 is even. So automatically I will proceed it 2, and it will be 2 times 3k, 2k plus 1, which is 2w plus 1. W is an integer value because k is an integer values. And we prove that n cube minus m cube is odd for the even numbers m. Now I have to continue with the second group. What if the m is odd? Can I substitute? Yes. m is odd يعني 2k plus 1 فبعبر عن m 2k plus 1 m plus 1 بصير 2k plus 2. Here 2 is a common factor, can be taken out, and this term will be even now. So because it is odd for all even number and it is odd for all odd number, that means it is odd for every integer number. Is that clear? This problem also you can prove it by contradiction. Try to do it yourself and send me your answer if you want me to check it for you. This question said for any integer n, 5 divide n whenever 5 divide n square. Again, this is a universal statement for any. كلمة any معناتها this is for all integer n يعني n belong to z. عندي هني whenever. This keyword whenever أقدر أعبر عنها بالimplies statement. صح؟ With the keyword whenever, this will be the premise and 5 divide n will be the conclusion, because whenever start with the conclusion, whenever premise. So the premise 5 divide n square should be here. 5 divide n square نعبر عنها n square divisible by 5. لما أقول الخمسة تقسم n square يعني معناتها n square تقبل القسمة على 5 divisible by. And 5 divide n معناتها n divisible by 5. So now this English can be converted into this symbolic form. For all n belong to z, if n square divisible by 5, then I can conclude in n divisible by 5. وكلمة n square divisible by 5 أعبر عنها n square equal 5k. و n divisible by 5 أعبر عنها إن ال n equal 5k. هاي معناتها divisible. لما تقبل القسمة على 5 يعني 5k, 5w, 5s, 5 whatever, something multiple by 5. If you look over your premise here, you will find ال n square موجودة هني وال n موجودة هني without power. هل أستخدم الدايركت method؟ No. ليش؟ If I choose a direct method, my assumption بيكون n belong to z والpremise. My goal is to calculate the n. So it will be difficult to calculate the n from the n square. I have to deal with the square roots. فمتى ما شفتون إن الباور هي اللي موجودة في البريمس والN العادية موجودة في الكونكلوجن without power، لا تفكروا في الدايركت. Think about the contrapositive أو contradiction. Now for here I will think about the contrapositive. شنو معنات contrapositive? I have to change positions with negations. So the contrapositive will be that for all n belong to z, n not divisible by 5, this should be in a premise. بدلت المواقع حطيت معاها not negation. Then n square not divisible by 5. What is my assumption now? I will assume احنا قلنا عقب ما نحط الكونترابوزيتيف نثبت الكونترابوزيتيف directly معناته الدومين and the premise should be in الاسsumption. عدل؟ لازم البريمس I should include it in my assumption. So I will assume ان ال n belong to z and ال n is not divisible by 5. يعني ال n is an integer number and this number is not divisible by 5. لأن الأرقام في الزي يا تكون divisible by a given number or not divisible by a given number. So I don't care about the n that they are divisible by 5. I care about the n, the integers that are not divisible by 5. And my goal is to show that n square is not divisible by 5. Let's go to the paint here and talk about divisibility. شنو معناه divisible؟ يعني لو خذينا كل الأرقام الانتجر z وجيت أعبر عنهم بالديفيزبل، مثلا في الكيس مالتنا 5، الأرقام في الزي يا إني هي تكون divisible by 5 5 فأعبر عنها بصورة واحدة فقط. أي رقم أقول عنه divisible by 5 5k 5w 5f 5s whatever. When I say that the number is not divisible by 5, how many forms to represent not divisible by 5? يعني when I divide over 5, if the number is not divisible by 5, there is remainders. هني there is no remainder. The remainder is 0. فactually plus 0 nothing يعني معناته ما أحتاج. فلما أقول any number divisible by 5 5k divisible by 10 10k divisible by 100 100k. ليش؟ Because there is no remainder. But here there will be a remainder. How many remainders if divisible by 5؟ يكون عندي 4 remainder. فبتكون عندي الفورم to represent not divisible by 5 some numbers with remainder 1, some numbers with remainder 2, some numbers with remainder 3, another numbers will be with remainder 4. هل في عندي remainder 5؟ لا. When I reach 4 after 5 خلاص يصير divisible. خلنا ناخذ example على هاي. 1 is divisible by 5? No. It's 5 times 0 plus 1. 2 divisible by 5? No. It is 5 times 0 plus 1. 3 divisible by 5? No. 5 times 0 plus 3. 4 divisible by 5? No. It's 5 times 0 plus 4. 5 divisible by 5? Yes. 5 times 1. No remainder. 6 بيصير 5 times 1 plus 1. صار من group remainder 1. 7 من remainder 2. 8 من remainder 3. 9 من remainder 4. 5 times 1 plus 4. من أوصل لل 10 بتصير 5 times 2. There is no remainder. So the remainder, possible remainder for any integer is the integer minus 1. يعني لو جيت قلت لكم أمضي remainder not divisible by 7. divisibility بتكون 7k بينما not divisible بيكون 7k plus 1 plus 2 لما أوصل plus 6 بيكون عنده 6 forms حق أعبر عن not divisible by. هذه لازم تتذكرونها. والريميندرز من 1 إلى ال n minus 1 يعني عندي 5 إلى 4. Now if you remember here we said that we will assume ان ال n belong to z and ال n is not divisible by 5. We have to show that ال n square is not divisible by 5. So can I prove that ال n not divisible by 5 for every integer not divisible by 5? I cannot represent not divisible by 5. I can represent it not divisible by 5 وقلنا by 4 different forms. So I will divide my domain in my assumption in 4 different cases. Because I have 4 different forms to represent a not divisible by 5. When I say n not divisible by 5 معناته ممكن تكون with remainder 1 ممكن with remainder 2 ممكن with remainder 3 أو 4. In each case I have to show what is n square. أحسب n square. I know that n is equal to 5k plus 1. أسوي لها squaring. أوزع الباور. لازم يكون عندي هني one of the remainder. هني عندي 1 فأخذ 5 as a common factor between the rest. So I get the form 5w plus 1. Now 5w plus 1 معناته n square also not divisible by 5. معناته it's proved for the first category. هل أوقف؟ لا. The statement said for all. الcontrapositive تقول for all. يعني I have to prove it for every case. أيا كان نوع n أيا كان الريميندر ماله لازم أسوي له powering إلى square. أسوي له squaring powering 2 بعدين أطلع n square وأشوف إن هي again another general form of not divisible by 5. لما تجون هني بتشوفون عندكم يطلع في الباور 9. 9 is one of possible remainder? No, it's not. So please, you can take 9 out and you put something equivalent to 9. 5 plus 4. ليش 5 plus 4؟ ليش ما قلت 6 plus 3؟ لازم one of these number divisible by 5 عشان أقدر أخذ عامل مشترك. I can take ال 5 a common factor and the other one should be one of the possible remainder. So 5k plus 3 all square أعطتني the form of 5w plus 4. Again, not divisible by 5. And again, we will do the same thing with the last group 5k plus 4 and you will get that the n square is not divisible by 5. Is that clear? So we choose here proof by contradiction لأن نبي نغير أماكن ال n وال n square وعرفنا شلون نعبر عن divisible وشلون نعبر عن not divisible. Okay? So you have to go through the cases to prove for each case because not divisible ما يكون عندها one form يكون عندها more than one form. The same problem, you can prove it by contradiction. And to prove it by contradiction, your assumption will be something different. في الproof by contradiction ما عندي assume to show. Assume و to show موجودة في الdirect وفي الcontrapositive. The proof by contradiction, you have only an assumption, only. Your task is to find a contradiction within your assumption. So here I am assuming the negation. What is the negation of the statement? The statement said for all n belong to Z, n square divisible by 5 implies n divisible by 5. So you are assuming that there exists n. أول شيء أحول لquantifier. إن that there is أو some integers if you are writing in English, okay? There exists and belong to Z such that implies a statement يعني premise and not conclusion. يعني I'm assuming إن ال n square divisible by 5 but ال n not divisible by 5. I am assuming the negation of the statement. هني and يعني this is true and this is true in my assumption. I can start from any one of them. Where I will start from here. ليش؟ لأن ال n موجودة هني. ال and يعني both of them are true صح؟ So either to start from here or start from here. But I will start from this side because I can calculate ال n square from ال n. So I will say, since n not divisible by 5, then I will go through the cases, because not divisible by 5 has 4 different forms. I have to search لأن exist لا. I have to search for integer n under these 4 categories where n not divisible by 5 and n square divisible by 5. So I will calculate n square to find n square divisible by 5 or not. So here I will calculate n square similar to what we did previously. We find it is not divisible by 5. So this is a contradiction. Did I find n? No, n is not under this category. So contradiction. I have to stop. No. Maybe here n is not exit in this group. It's exit here or exit here or exit here. So to say that this assumption falls, you should find the contradiction in each case. معناته n not exit. لأن الستيتمنت exist. لو كانت الستيتمنت universal contradiction واحد يخليني I stop. But لأن this is exist معناته لازم أثبت إنه هو not exist everywhere in all cases. So again you should find here a contradiction. You find here a contradiction and you find here a contradiction. Do you have any questions? Have any questions? This is for today. We focus on the 3 different methods: proof by contradiction, proof by directly أو proof by contrapositive. الcontrapositive بس حق implies statement, and we go for it if we want to calculate إذا في البريمس عندي squaring أو cube أروح أغيرهم عشان أحصل proof by contradiction. Any more questions? Good. This is for today. I will share with you the slides on Blackboard. Inshallah, by next week, we will take homework number 3. Homework, according to your course outline, homework number 3 should be the last homework. I think from the course outline, we have only 3 homeworks. But I don't know if your instructor will add another homework or not on proof by induction. This is for today, and thank you very much.